Hello, hello. We are back with example 2A, finding equations of direct variation. So this problem states that we need to find each equation of direct variation given that y varies directly with x. And then it says y is 54 when x equals 6. Now, what does all this mean? Okay, what we need to know is that when we see this y varies directly with x, y's varies directly with x, y's vary directly with x, that is giving us the direct variation equation. That's basically saying, hey, you need to go ahead and write down y equals kx, because that's what this means. Y equals kx means y varies directly. It's directly across from x. Now there's this other bit of information. It says y is 54 when x is 6. Now what is that? What that is they're actually giving you a point which is going to be on this equation. So the point is x, y. And so you just go ahead and plug that in. So y is 54, so that means 54 is the same thing as y, and x is 6. And that is the point. So to go ahead and figure out what this equation is, we know that this point is in this equation, so we're just going to substitute it in. So this is our y is 54, and so instead of writing y, I'm going to write 54 equals, we need to figure out what the k is, and the x is 6. So we're just going to solve and isolate for k. To do that, we're going to do the inverse operation. We're going to get k by itself. Right now there's a 6 around it. It's 6 multiplied by k. Inverse operation says we're going to do division to both sides. And 54 divided by 6 is 9. So that means that k is equal to 9. Okay, there we go. We know our constant of variation. Now it's just very simple to write a direct variation. We just go ahead and substitute that number in for k, and we get y equals 9x. Perfect. That is our direct variation equation. Done. Now we need to graph it, okay? We know that there is no number out here, so that would be our y-intercept. So we know that our y-intercept is actually equal to 0, and our slope is actually the same thing as k, so our slope is equal to 9 over 1. We're going to graph it. Y-intercept is at 0. Done. From here, we're going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1 right there. And then do the opposite from 0. Go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and go over 1. From there, we're going to connect the dots. Like so, and boom shakalaka, we have our picture of our direct variation equation. Perfecto. On to the next one. Okay, we're doing a direct variation. I'm going to go ahead and write that formula, and you should every single time. Y equals kx. They give us this point. They're saying x is 12 when y is 15. We know that that's a point. We're going to go ahead and substitute that in. The x is the 12, and the y is 15. So we just substitute that point into our direct variation equation to go ahead and figure out what y is. So instead of writing y, I'm going to write 15 because 15 is the same thing as y. K is what we're trying to figure out. And the x is actually equal to 12. So we're going to isolate k, get k by itself. Right now this is 12 multiplied by k, so I'm going to do the inverse operation of multiplication, which is division. So I'm going to divide both sides by 12. I end up with 15 over 12 is equal to k. I need to reduce that fraction. I know that 3 goes into both of them. 3 goes into 15 5 times. 3 goes into 12 4 times. I'm left with 5 over 4. Or if I want to use the wonderful, magnificent symmetric property of equality, k is the same thing as 5/4. So there we have it. We found our constant variation, but we need to find our direct variation equation. So we just need to substitute that value into here in for k, and we get y equals 5/4 x. And there we have it. That is our direct variation equation. And now it is time to graph it. Well, we know that there is no number out there, so that means that that number must be 0. Our y-intercept is equal to 0, just like it is on every other direct variation out there. And then our k is actually the same thing as our slope, so our slope is equal to 5/4. So we're going to go ahead, just like we graph our lines, and we graph the y-intercept first of 0, and then from there the slope, up 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4. We're going to go here again and do the same thing, but in opposite. We're going to go down 5, 1, 2, 3, 4, 5, and over 4 this way, 1, 2, 3, 4. And there we go, connect the dots. And we have our wonderful direct variation. It's a picture of the graph y equals 5/4 x. And now it is your time to shine. It is time to check it out with example 2a. And where is our friend? You're going to have to find the direct variation equation for 2a and 2b and graph both of them. Okay, where's our friend the pause dragon? Oh, there it is, reminding us that we need to pause our electronic device. Go ahead and work the problems out and come back in a bit and check them. All right, see you in a bit. Bye. All right, we are back. We're going to find each equation of direct variation given that y varies directly with x. Y varies directly with x. That lets us know that immediately we need to go ahead and write down the direct variation equation, which is y equals kx. And then we have this lovely little bit here, which says y is 24 when x is 4. And we know that that just means that they're giving us a point. So they're giving us a point on our equation, which is y is 24, so the 24 is here, and x is 4. So there we go. We need to go ahead and substitute those values into our equation and figure out what k is. So instead of writing y, I'm going to write 24 because that's what y equals. And then k, that's what I'm trying to figure out. The x is equal to 4. And I'm going to isolate 4, so I'm going to divide both sides by 4. I get 24 divided by 4, which is 6 equals k, or k equals 6 if I'm going to use the symmetric property of equality. Now I just need to write the equation. No sweat. Stick 6 in here for k, and it is a done deal. Y equals 6x, and that is our direct variation equation. Now it's time to graph it. We know it's a direct variation, and our y-intercept to 0, and our slope is actually the same thing as k. It's a number right there. So our slope is actually 6/1. So we graph our y-intercept and then graph the slope from that. Up 6, 1, 2, 3, 4, 5, 6, and over 1. And we could do the opposite. We could go down 6, 1, 2, 3, 4, 5, 6, and over 1 this way. After that, we're just going to connect the dots. And there we go. There's our equation. If you got that right, awesome job. On to the next one. Let's do this. Okay, so we're still doing direct variation equations. We need to go ahead and write our formula, y equals kx, and we know that x is 28 when y is 14, so that's nothing more than a point. An x value and a y value. Our x is 28 and our y is 14. We go ahead and substitute those values into the equation to figure out what k is. Y is equal to 14, so that's what I'm going to write, equals k, and x is 28. We're solving for k, so we're going to divide both sides by 28. Okay, I am left with k is equal to 14/28. Now, what goes into 14 and 28? I'm going to say 14 does. 14 goes in there one time, 14 goes into 28 two times. I'm actually left with 1/2 equals k, or the symmetric property of equality tells me that k is equal to 1/2. Okay, no sweat. Now it's just time to write our direct variation equation. I'm going to substitute 1/2 in for k here, and then there we have it. Y equals 1/2 x, and that is our direct variation equation. And now it is time to graph. We know that our y-intercept is equal to 0 because it's always equal to 0 with direct variation equations, and also we know it because there's no number out there, so it must be 0. And then our k, 1/2, is actually the same thing as our slope. So from here we're going to graph away. Y-intercept right there, and then we're going to do a 0, and then our slope, up 1/2, up 1/2. And go the opposite, down 1/2 this way, 1, 2, down 1/2 this way. And then let's play connect the dots. Connect the dots. I'm trying to connect them. Connect the dots, and there we go. We have our wonderfully straight direct variation equation that goes through the origin. Y equals 1/2 x. If you got that right, yoke it ikimashita. You did a wonderful job, and I will see you next time. Goodbye.